AIM-7 Sparrow. The AIM-7 Sparrow air intercept missile is an American, medium-range semi-active radar homing air-to-air missile operated by the United States Air Force, United States Navy, and United States Marine Corps, as well as other various air forces and navies. Sparrow and its derivatives were the West's principal beyond visual range BVR air-to-air missile from the late 1950s until the 1990s. It remains in service, although it is being phased out in aviation applications in favor of the more advanced AIM-120 AMRAAM. The early Sparrow was intended primarily for use against larger targets, especially bombers, and had numerous operational limitations in other uses. Against smaller targets, the need to receive a strong reflected radar signal made achieving lock-on at the missile's effective range difficult. As the launching aircraft's own radar needed to be pointed at the target throughout the engagement, this meant that in fighter vs. fighter combat, the enemy fighter would often approach within the range of shorter-range infrared homing missiles while the launching aircraft. Additionally, early models were only effective against targets at roughly the same or higher altitudes, below which reflections from the ground became a problem. A number of upgraded Sparrow designs were developed to address these issues. In the early 1970s, the RAF developed a version with an inverse monopulse seeker and improved motor known as Skyflash, while the Italian Air Force introduced the similar Aspide. Both had the ability to be fired at targets below the launching fighter look down, shoot down, were more resistant to countermeasures, and were much more accurate in the terminal phase. This basic concept was then made part of the U.S. Sparrows in the M model for monopulse, and some of these were later updated as the P model, the last to be produced in the U.S. Aspides sold to China resulted in the locally produced PL-10. The Japan Self-Defense Forces also employ the Sparrow missile, though it is being phased out and replaced by the Mitsubishi AIM-4. The Sparrow was also used as the basis for a surface-to-air missile, the AIM-7 Sparrow, used by a number of navies for air defense. Fired at low altitude and flying directly at its target, although the range of the missile in this role is greatly reduced due to the lower atmosphere. With the retirement of the Sparrow in the air-to-air role, a new version of the Sea Sparrow was produced to address this concern, producing the larger and more capable AIM-162 AMRAAM. Development. Sparrow I. Sparrow emerged from a late 1940s United States Navy program to develop a guided rocket weapon for air-to-air use. In 1947, the Navy contracted Sperry to build a beam-riding version of a standard 5-inch 127 mm H-bar, the standard unguided aerial rocket, under Project Hotshot. The weapon was initially dubbed KAS-1, then AIM-2, and from 1948 on, AIM-2. The airframe was developed by Douglas Aircraft Company. The diameter of the H-bar proved to be inadequate for the electronics, leading Douglas to expand the missile's airframe to 8-inch 203 mm diameter. The prototype weapon began unpowered flight tests in 1947 and made its first aerial interception in 1952. After a protracted development cycle, the initial AIM-2 Sparrow entered limited operational service in 1954 with specially modified Douglas F-3D Skype all-weather carrier night fighters. In 1956, they were joined by the McDonnell F-3H-2M Demon and Vought F-7U Cutlass fighter aircraft. Compared to the modern versions, the Sparrow I was more streamlined and featured a bullet-shaped airframe with a long pointed nose. Sparrow I was a limited and rather primitive weapon. The limitations of beam riding guidance, which was slaved to an optical sight on single-seater fighters, and radar with night fighters, restricted the missile to attacks against targets flying a straight course and made it essentially useless. Only about 2,000 rounds were produced to this standard. Sparrow II. As early as 1950, Douglas examined equipping the Sparrow with an active radar seeker initially known as AIM-2 Sparrow Roman II, the original retroactively becoming Sparrow I. In 1952, it was given the new code AIM-3. The active radar made the Sparrow Roman II a fire-and-forget weapon, allowing several to be fired at separate targets at the same time. By 1955, Douglas proposed going ahead with development, intending it to be the primary weapon for the F-5D Skylancer interceptor. It was later selected, with some controversy, to be the primary weapon for the Canadian AMRAAM supersonic interceptor, along with the newest fire control system. For Canadian use and as a second source for U.S. missiles, Canadair was selected to build the missiles in Quebec. The small size of the missile forebody and the K-band and /APQ-64 radar limited performance, and it was never able to work in testing. After considerable development and test firings in the US and Canada, Douglas abandoned development in 1956. Canadair continued development until the Arrow was cancelled in 1959. Sparrow X. A subvariant of the Sparrow I armed with the same nuclear warhead as the AIM-1 Genie was proposed in 1958, but was cancelled shortly thereafter. Sparrow Roman III, Min-3. Concurrently with the development of the Sparrow I in 1951, Raytheon began work on the semi-active radar homing version of Sparrow family of missiles, the AIM-6 Sparrow Roman III. The first of these weapons entered United States Navy service in 1958. The AIM-6 was similar to the -6, but used a new thiokol liquid fuel rocket engine for improved performance. It also included changes to the guidance electronics to make it effective at higher closing speeds. The -6 was also selected to arm the Air Force's F-110 Spectre F-4 Phantom fighters in 1962, known to them as the AIM-101. It entered production in 1959, with 7,500 being built. Another upgrade reverted to a Rocketdyne solid-fuel motor for the AIM-6, which started production in 1963. The new motor significantly increased the maximum range to 35 kilometers 22 mi for head-on attacks. During this year, the Air Force and Navy agreed on standardized naming conventions for their missiles. The Sparrows became the AIM-7 series. The original Sparrow I and aborted Sparrow Roman II became the AIM-7 and an AIM-7B, despite both being out of service. The -6, -6A, and -6 became the AIM-7C, AIM-7D, and AIM-7E respectively. 25,000 AIM-7Es were produced and saw extensive use during the Vietnam War, where its performance was considered disappointing. The mixed results were a combination of reliability problems exacerbated by the tropical climate, limited pilot training in fighter-to-fighter combat, and restrictive rules of engagement that generally prohibited BVR beyond visual range engagements. The PK kill probability of the AIM-7 was less than 10%. U.S. fighter pilots shot down 59 aircraft out of the 612 Sparrows fired. Of the 612 AIM-7D/E/M-2 missiles fired, 97 or 15.8% hit their targets, resulting in 56 or 9.2% kills. 2 kills were obtained beyond visual range. In 1969, an improved version, the AIM-2, was introduced with clipped wings and various changes to the fusing. Considered a dogfight Sparrow, the AIM-7 was intended to be used at shorter ranges where the missile was still traveling at high speeds and in the head-on aspect, making it much more useful in the visual limitations imposed on the engagements. Even so, its kill rate was only 13% in combat, leading to a practice of ripple firing all four at once in hopes of increasing kill probability. Its worst tendency was that of detonating prematurely, approximately 1,000 feet in front of the launching aircraft, but it also had many motor failures, erratic flights, and fusing problems. An M-3 version included additional changes to the fusing, and an M-4 featured a modified seeker for use with the F-14 Tomcat. Vietnam War 1965–1973 records. Improved versions of the AIM-7 were developed in the 1970s in an attempt to address the weapon's limitations. The AIM-7F, which entered service in 1976, had a dual-stage rocket motor for longer range, solid-state electronics for greatly improved reliability, and a larger warhead. Even this version had room for improvement, leading British Aerospace and the Italian firm Alenia to develop advanced versions of Sparrow with better performance and improved electronics as the B Skyflash and Alenia Aspide. The most common version of the Sparrow today, the AIM-7M, entered service in 1982 and featured a new inverse monopulse seeker matching the capabilities of Skyflash, active radar proximity fuse, digital controls, improved ECM resistance, and better low-altitude performance. It was used to good advantage in the 1991 Gulf War, where it scored many USAF air-to-air kills. Of 44 missiles fired, 68.2% hit their intended targets, resulting in 24/26 54.5%/59.1% kills. 19 kills were obtained beyond visual range. The AIM-7P is similar in most ways to the AIM versions and was primarily an upgrade program for existing AIM series missiles. The main changes were to the software, improving low-level performance. A follow-on Block Roman II upgrade added a new rear receiver, allowing the missile to receive mid-course correction from the launching aircraft. Plans initially called for all AIM versions to be upgraded, but currently PEs are being issued as required to replace AIMs lost or removed from the inventory. The final version of the missile was to have been the AIM-7R, which added an infrared homing seeker to an otherwise unchanged AIM-7P Block Roman II. A general wind down of the budget led to it being cancelled in 1997. Sparrow is now being phased out with the availability of the active radar AIM-120 AMRAAM, but is likely to remain in service for several years. Foreign versions. Canada. As part of the Avro Canada CF-105 Arrow program, Canadair, now Bombardier, partnered with Douglas Aircraft Company in the development of the Sparrow Roman II AIM-3/AIM-7B. After Douglas dropped out of this program, Canadair continued on with it until the termination of the Arrow project. The AIM-3 Sparrow Roman II was unique in that it had a fully active radar guidance system. This combined both a radar transmitter and receiver in the missile, making it unnecessary for the pilot to keep the aircraft aimed at the target after firing the missile, unlike semi-active radar homing SAR missiles, which require continuous radar-assisted guidance throughout flight. This allowed the aircraft that fired the AIM-3 to turn away, prosecute other targets, and slash or escape from potential retaliatory missiles fired by the enemy aircraft during the time it takes for the Sparrow to reach its target. Despite the significant advantages of this design over SAR guidance, all subsequent models of the Sparrow use semi-active radar homing. To accommodate the active radar guidance system, the AIM-3 Sparrow Roman II had a much greater volume than its predecessor. Its size would subsequently set the precedent for all future Sparrow variants. In 1959, Canadair had completed 5 missiles based on airframes from Douglas and built 2 models from scratch when the program was cancelled with the cancellation of the Arrow. Italy. The Italian company Finmeccanica, now Leonardo S.p.A., Alenia DIFSA, licensed the AIM-7 Sparrow technology from the U.S. and produced its own version. Later in the 1980s, Alenia started to produce an improved version of the AIM-7 called the Aspide. Compared to the AIM-7E, it received a newer and improved monopulse guiding system that allowed for a better hit ratio and easier targeting of enemies at low altitude confused in the ground clutter. It also received a new and more powerful engine and new control surfaces. These control surfaces were all independent one of the others. This gave the missile a much better maneuverability compared to the AIM-7E and the English Skyflash that still used dependent control surfaces. People's Republic of China. The LA-60/FD-60/PL-10 is a family of PRC missiles developed by the Shanghai Academy of Science and Technology. There are 4 versions of the basic design, 3 of which are surface-to-air and 1 air-to-air. Soviet Union. The Soviet Union acquired an AIM-7 in 1968 and a Vimpel team started copying it as the K-25. The missile did not enter production as the AR-23 was thought to have better versatility, range, signal processing logic, and immunity from interference. K-25 work ended in 1971, but analysis of the Sparrow was later used to inform the design of the Vimpel AR-27, particularly the servomechanisms and movable wings. UK. British Aerospace licensed the AIM-7 ETWO technology in the 1970s, producing the Skyflash missile. Skyflash used a Marconi XJ521 monopulse seeker together with improvements to the electronic. It was powered by the Aerojet Mk52 Mod 2 rocket engine, later by the Rocketdyne Mk38 Mod 4. Skyflash entered service with the Royal Air Force RAF on their Phantom FG-1/FGR-2 in 1978 and later on the Tornado F-3. Skyflash was also exported to Sweden for use on their Viggen fighters. An upgraded version with active radar seeker, called Active Skyflash, was proposed by B. and Thompson CSF, but did not receive funding because the RAF opted for other missiles. Design. The Sparrow has 4 major sections: guidance section, warhead, control, and rocket motor. Currently, the Hercules Mk-58 solid propellant rocket motor. It has a cylindrical body with 4 wings at mid-body and 4 tail fins. Although the external dimensions of the Sparrow remained relatively unchanged from model to model, the internal components of newer missiles represent major improvements, with vastly increased capabilities. The warhead is of the continuous rod type. As with other semi-active radar-guided missiles, the missile does not generate radar signals but instead homes in on reflected continuous wave signals from the launch platform's radar. The receiver also senses the guidance radar. Principle of guidance. The launching aircraft will illuminate the target with its radar. In radars of the 1950s, these were single-target tracking devices using a nutating horn as part of the antenna. This caused the beam to be swept in a small cone. Signal processing would be applied to determine the direction of maximum illumination and so develop a signal to steer the antenna toward the target. The missile detects the reflected signal from the target with a high-gain antenna in a similar fashion and steers the entire missile toward closure with the target. The missile guidance also samples a portion of the illuminating signal via rearward-pointing waveguides. The comparison of these 2 signals enabled logic circuits to determine the true target reflection signal, even if the target were to eject radar reflecting chaff. Operators.